Okay, so we're going to start solving systems of equations by elimination. This is the third and final method for solving systems. So again, for the third time, I'm going to explain to you that one of three things can happen. You can have intersecting lines, so you could have one solution. You could have parallel lines, which means that there's no solution. You could have the same line, which means infinitely many solutions. So again, when you get a statement that something's not equal, you know there's no solution. If you get something that's equal, then you know that there's infinitely many solutions. So we've talked about three methods so far. Starting today is our third method. We've done graphing, we've done substitution, and today is the last one, elimination. So today the only type of problems we're going to look at are things where we can find the opposites. So exactly a 2x and a negative 2x, a negative 5y and a 5y. What we're going to do is we're going to add those together, and then we're going to plug that value that we get when we solve those back into the original, and then we're going to check to make sure they work in both equations, and we'll write our answer as an ordered pair. So the first example, this is called elimination. It's also just a method where we're adding columns together. So you want things to match up perfectly, and as long as your x's are above your x's and your y's are above your y's and your numbers are above your numbers with your equals, you're good to go. If you notice, you've got a 1y and a negative 1y. So when we start adding these together, we have 1 plus 1, which is 2x, and here we get 0, and then this equals 4. Divide by 2 on both sides, and we get x is 2. Then what we'll do is we'll take and we'll plug this value back into one of the two original equations. It doesn't matter which one you choose. I just picked the first one because they were all positives. So I'm going to plug in 2, and then I'll solve. I'll subtract 2 to get y by itself, and I get y is equal to negative 1. So my ordered pair answer would be 2, negative 1. Again, we can check our solution. So I'll do a check in blue. If I plug in 2 for my x and I plug in negative 1 for my y, I have 2 plus negative 1, which is 1. And then here I'll have 2 minus negative 1, which is 3. And I'm done. In the next problem, what I have, if I start adding my columns together, I do have a positive 5 and a negative 5. So those create 0. This gives me 5x. This gives me 25. Divide by 5 on both sides, and I get x is 5. Then what I'm going to do is pick one of the two equations. I'll just pick the first one. And then I'll substitute that back in. So I get 3 times 5 plus 5y equals 15. And then I'll go ahead and solve this equation. So I end up with 3 times 5, which is 15, plus 5y equals 15. Subtract by 15 on both sides, and I get 5y equals 0. Divide by 5, and I get y is 0. So my final answer will end up being x comma y. What I'm going to do now is just check my answer. Put in 5 here, put in 0 here, and you get 15. Because 3 times 5 is 15, and 5 times 0 is 0, so 15 plus 0 is 15. And then here when you check, you've got 2 times 5, which is 10, and then negative 5 times 0 is 0, so 10 plus 0 is 10. We can fit one more in. On this one, we're going to, again, notice that I have a y and a negative y, so those fall out. We get 7x equals, when you add those together, you get 21. Divide by 7 on both sides, and we get x is 3. So I'm going to plug this back into my original first equation again. Plug that in for the x, so I have 4 times 3 plus y equals 13. Solve this equation. This is 12 plus y equals 13. Minus 12 minus 12, y is 1. And then I'm going to have x comma y. I can check my solution. Plug in 3, plug in 1, that gives me 12 plus 1, which is 13. Plug in 3, plug in 1, I have 9 minus 1, which is 8, so they both work.